center tank, to main wing tanks, to collector tanks, and then to the engine. Air management. While in flight, pressurized air for crew and passenger spaces is collected from both the low and high pressure compressors inside the engine through bleed air valves. This hot bleed air is cooled with outside air through ram air ducts in the wing-to-body fairing before proceeding through the climate control system for further processing as needed. There's also a low-pressure ground connection for hooking up to an external air conditioning source while grounded. A network of air outlet tubes connects the system to cabin controls above each seat and in other areas of the plane. There are equalization valves between pressurized compartments to maintain equilibrium, and an outflow valve on the pressure bulkhead behind the forward cargo compartment. Hot bleed air is also used in the anti-ice and fog system. Perforated piccolo tubes in the wing slats use bleed air to melt ice. The air exhausts out the back of the slat. The front engine cowl is heated with hot bleed air and has small exhaust slots at the bottom. Windshields and side windows in the cockpit have a heating film between layers of glass. Electrical. There are 2 electrical equipment bays in the underside of the plane's body. The forward equipment bay is just behind the flight deck, and the mid-equipment bay is tucked behind the wings. These bays are filled with a dizzying array of electronics, computers, etc. to run the many systems on this complex airplane. Generators attached to each engine are the main source of electrical power. The APU can provide backup power. 3 separate electrical power centers control distribution to critical systems like landing gear, the high lift flight system, brakes, tire pressure monitors, and many more. There are 2 primary flight control computers in the forward equipment bay, with backup alternate flight computers in the mid-equipment bay. Hydraulics. There are 3 separate hydraulic systems. Systems 1 and 2 are redundant in case one system fails. The third system operates only in emergencies. The base components for System 1 are nestled in the port side wing-to-body fairing. System 2 mirrors this arrangement, but on the starboard side. Hydraulic actuators, fitted in tight, small spaces, run many critical flight control surfaces. For example, the spoilers, elevators, rudder, and so on. There are often multiple actuators to operate a surface, connected to separate hydraulic systems, again for redundancy. Hydraulic System 1 controls the upper rudder actuator, left elevator outboard actuator, left thrust reverser, left and right multifunction spoilers 1 and 3, the flap power drive unit, left and right flap brake, left and right ground spoilers, and landing gear. Hydraulic System 2 powers the middle rudder actuator, the right elevator outboard actuator, right thrust reverser, the right and left multifunction spoiler 4, the left aileron outboard actuators, nose wheel steering, the slat power drive unit, and the left and right slat brakes. Emergency System 3 can power the lower rudder actuator, left and right elevator inboard actuators, left and right multifunction spoiler number 2, left and right aileron inboard actuators, left and right slat and flap brakes, and the ram air turbine stow actuator. Water and waste. This plane has 3 bathrooms, one up front behind the flight deck, and 2 at the back. There are also sinks at the forward and rear galley stations. Pumps pull water from a 42-gallon tank anchored under the rear floor panels. A heated blanket and heated water lines keep the water from freezing. A water heater near each sink passes hot water through a water mixer to regulate faucet temperature. Gray water from the sinks is drained through heated gray water drain masts at the front and mid-rear of the plane's underside. Gray water drains in flight and evaporates in air. Black water from onboard toilets is stored in a waste tank and emptied after landing. Both air and water are separated from waste as it enters the tank. At altitudes below 16,000 feet, a vacuum generator creates suction to pull waste into the tank. Above 16,000 feet, the vacuum generator is bypassed, and the pressure difference inside and outside the plane creates the necessary suction forces. Emergency systems. The forward and aft galley stations have first aid kits, flashlights, fire extinguishers, crew life vests, megaphones, and portable oxygen cylinders that provide 15 minutes of oxygen to crew members. Oxygen generators are positioned above each row of seats. If the cabin loses pressurization, masks deploy, and a chemical reaction generates about 13 minutes of oxygen. An emergency locator transmitter automatically activates if a crash is detected. This transmitter emits a signal that can be used to help locate the aircraft. An aircraft identification module provides the location transmitter with aircraft-specific data. Door-mounted slides are packed into a bottom compartment in each